Hello, college algebra student. This video is for 5.2 part 1. We're looking at two types of new function called power function and polynomial functions. Polynomial functions is made up of power functions. So you can say power functions are foundation of polynomial functions. So what is a power function? A power function is a function of a constant k, which is just we call it a coefficient, like a number like 5, -2, and then x to the p. P is the power. So all the toolkit function are power functions. So it has only one term, a constant, and also a power, which is the x to the something. So for example, two particular one that we have is f of x equal to x squared is quadratic, but it is 1 times x squared, right? This is a special power function in that the power is a whole number. So some of them had a power of, 1 over x, like the reciprocal function is f of x equal to 1 over x. So that is x to the power -1 is still called a power function, but it's not a whole number, not a positive whole number. So the two that is positive is x squared and x cubed. So let's look at the graph of it. Everybody should be very familiar with x squared being like this. So it would go on forever on the negative side and also on the positive side. On the left, it rise up on the left and right. For x cubed, it's like an S shape. That means on the left, it drops, but on the right, it rises, right? It drops on the left and it rises on the right. And so what about other functions? So other whole number power functions. So in general, if n is a whole number, so we are looking at whole number means no negative. It's just 1, 2, 3, 4. So what about x to the 4, x to the 5, x to the 6, x to the 11? How do they look like? It turns out that if the coefficient is positive and is even power, they would really look like quadratic. Okay, so they will have a positive coefficient, even power. They will go up like that. They would be more flat here, but they will always go up when x is infinity and x is negative infinity, both sides. The f of x, the y will also go to infinity, rise up on both left and right. But if it is a odd power, it would just look like x cubed. So it's kind of like similar to it, except it is more flattened in x when x is approaching 0. So there's always still like that, except this is fatter. So there is, you can say when f of x is positive, when x approaches infinity, f of x also approaches infinity. When f of x is negative, when x approaches negative infinity, f of x also approaches negative infinity. They go to the infinity on this side, so left is they drop on the left and then rise on the right. So when the coefficient is positive. When the coefficient is negative, then it's a reflection. So the even power would become flat like this. So it's very flat here, but it would be dropping left and right. So whenever x approaches infinity or negative infinity, your f of x is just negative. You can think of it as a reflection, less than 0. When k is less than 0 in odd power, it's also a reflection. So reflect so that this become like that. So that means when x approaches infinity, f of x actually go to negative infinity. It drop at the right. When x approaches negative infinity, f of x will go to infinity. They go different direction. They go the same direction. So that's actually the 4 possible cases of power function. If you have x to the something, which is a whole number, this excludes square root or negative. So something more about function. So example 1 was, okay, if I have a power function of -3x to the 6, what do you think? How can you describe the end behavior? So the end behaviors are determined by their coefficient and also by their power, whether it's even or odd. So let's look at the power. Is even. Even means it is either always going up or going down, depending on the sign, right? So if it's a positive, it's going up. This is negative, so it would both go down. So kind of like the reflected quadratic. So when x approaches infinity, f of x would go to negative infinity. When x approaches negative infinity, f of x also go to negative infinity. No matter what, when x is really big or really small, it would go to negative infinity. So that's kind of the shape. So that's power function, pretty straightforward. It only turns once, and it only turns at x equal to 0. When the power is higher, then it would be just, more flat and close to 0. Let's look at the second big set, which is polynomial function. Polynomial functions are usually like this. It would consist of individual power function term with whole numbers. So you would have x and a to the n, x to the n. So a to the n, not a to the n, a n, x to the n, or we can say a sub n, x to the n, a sub 2, x to the second, a sub 1, x plus a 0. So it's all a list of all these coefficient and an x to the n, where n is a integer, right? All the power is integers. Or no, not integers, whole numbers. All whole numbers and also a constant. So if you have all these x to the something, which is a whole number, add together, it become a polynomial. So out of all these terms, there is one term that is very important called the leading term. Leading term is not the first term that you write out because sometimes you can switch them around. Leading term is the one with the highest degree. What is a degree? Degree is the exponent. If it has the highest exponent, then the whole term itself is called the leading term. Okay, and the leading term represents the whole polynomial because, and also when we say what is the degree of this whole polynomial, we usually refer to the degree of the leading term. And there is another term called the leading coefficient. So in this particular case, it's the first one. The leading coefficient is the coefficient of the leading term. Okay. So why are we so into just the leading term? There's a lot of terms in the whole polynomial functions. It turns out that if we know what the leading term is, we know the degree. We can tell actually the maximum number of zeros or x-intercept is the same as the degree. So if you have x to the 4th, you can have maximum 4 zeros. And then the polynomial also turns. Polynomials also usually go up at the up or down to infinity at the end, but in the middle they wiggle or they turn. So sometimes they go like this, or sometimes they go both way down, whatever. But they turn in the middle. But how many turns do they have? The maximum turn is n minus 1, depending on the degree of the leading term. So a polynomial graph always consists of terms and also end behavior that go to infinity. They would not flat out. It would always go to infinity or negative infinity depending on the leading term. So the end behavior of the polynomial function is determined solely by the leading term an x to the n. The leading term is the one with the highest degree. So let's practice this. This is a polynomial function. We don't know what is in here, so I think they are written in decreasing power. So the highest power is 3x to the n, to the 5. So we have another term that's called 3x to the 4th. What is the degree of this 3x to the 4th? It is degree 4. Degree means power. What is the coefficient of 7x or minus 7x? I think this is a minus. So coefficient is the number that multiply to that term, so it's -7. What is the leading term of this function? highest exponent. Leading term is 3x to the 5. So this is really important. Okay. What is the degree of f of x? The degree is the same as the leading degree. What's the leading degree? Leading term's degree is 5. So the whole polynomial also has degree 5. What's the leading coefficient? Leading coefficient is looking at the leading term, 3. What's the maximum turns? I have x to the 5, so I can turn 4 times. Maximum. You might turn less. What are the maximum zeros? So maximum 0 is the same as the degree by. Same as the degree. What are the end behavior? So it turns out that's what we said before. The end behavior is determined by the leading term. So my leading term is 3x to the 5. You will say, look at determined by 3x to the 5. So 3x to the 5 is odd degree, so it is, and then it's positive. So it would be rise to the right, drop on the left, right? So we will say, we think of it that way. So we will say when x approaches infinity, f of x also approach infinity. When x go to negative infinity, f of x go to also negative infinity. So that's the end behavior. It's as if you only have one term, or the other term doesn't change the end behavior. End behavior means when x is very large. Example 2, I have a polynomial that is factored, not written out as term by term. But if you expand it out, it will be, right? So what is the leading term? Is it x? What do we do? So we will try to expand it, but not everything. We're just interested in expanding the highest degree term. So what is the highest degree here? So I have 2x. I have x. Oh, and a square. So this becomes x squared. So we would say 2x times x squared times this one is also x squared. So it will be 2x to the 5. So we have, this is being the leading term. So 2x to the 5. And that's how you find out. You don't need to expand everything out. Only the leading term though. What is the end behavior? Well, again, end behavior depends on the leading term. And this is an odd power, right? And positive, so just like last one. So it would be drop to the left side, rise to the right side. So again, the same. The whole polynomial has a lot of term, but it's at the end is the same as the leading term. So when x approaches infinity, f of x, or the g of x, this is g of x, this function, not just this one, not just this term, but the whole g of x will approaches infinity. When x approaches negative infinity, g of x will approaches negative infinity also, left, right. So let's look at this too. So someone give us a polynomial function. We have no formula. So we can actually talk about how many turns do we have. 1, 2, 3, right? We have 3 turns. So we have how many zeros? Zeros are the x-intercept. You have 2 0. So if we have 3 turns, at least it is 4 degree. If 4 degree has 3 turns. It would be at least 2 degree 2, but because you have more turns, so it would be 3, 4. Number of turn is only 2, right? So that means I could have degree 3, but number of 0 is 1, 2, 3. So 3, 0. So degree is at least 3, because then it's exactly, the number of zeros should be exactly at least the same as the number of zeros. So that's all we have for part 1, and then we will actually, that's actually all of chapter 5.2, and we'll do 5.3 in the next video.